close your eyes and let the darkness wrap around you like a soft blanket. In this gentle quiet, something magical is happening all around you. Light is dancing. Even now, in what seems like complete darkness, tiny messengers of light are moving through your room. They slip through the smallest cracks around your window. They whisper through the keyhole of your door. They carry stories from distant stars and the warm glow of streetlights outside. These messengers have a name. Scientists call them photons. But tonight, you can think of them simply as light's children. Each one is so small that billions could dance on the head of a pin. Yet each one carries energy, memory, and mystery. Imagine you could shrink down, smaller than the tiniest ant, smaller than a grain of sand, smaller than anything you've ever seen. You would enter a world where the rules change completely. A world where light reveals its deepest secret. In your everyday world, light seems simple. You flip a switch, and brightness fills the room. The sun rises, and day begins. Light travels in straight lines from here to there. It bounces off mirrors and bends through water. Everything makes sense. But when you peer deeper, when you look closer than anyone looked for thousands of years, light begins to surprise you. Sometimes, light behaves exactly like you would expect tiny particles to behave. Picture throwing marbles at a wall. Each marble hits the wall in one specific spot. It travels in a straight line. It bounces predictably. When scientists first discovered photons, this is exactly how light seemed to work. Each photon carries a tiny packet of energy, like a marble carries momentum. When photons hit your eye, they deliver their energy to special cells that send messages to your brain. This is how you see. Particle by particle, light builds the world of colors and shapes around you. But here comes the mystery that changed everything. Sometimes, in certain experiments, light doesn't act like particles at all. Instead, it flows like water. It ripples like waves on a pond. It spreads out, curves around corners, and creates patterns that no particle could ever make. Think about waves on the ocean. When two waves meet, they can add together to make a bigger wave. Or they can cancel each other out, creating calm, flat water. This is called interference. Particles can't do this, but light can. Scientists discovered this more than 200 years ago, and it puzzled them completely. How could light be both a particle and a wave? How could something so familiar hide such a strange double nature? The answer, they learned, depends on how you look. When you set up an experiment to catch light acting like particles, you find particles. When you design an experiment to see light as waves, you discover waves. Light seems to know what you're looking for. It becomes whatever the situation requires. This isn't magic, though it feels magical. This is quantum mechanics. This is the hidden reality that governs everything smaller than atoms. In this realm, the either-or rules of your everyday world dissolve into both impossibilities. Right now, as you rest in your bed, light from your alarm clock display is reaching your closed eyelids. Each photon began its journey as pure energy inside a tiny electronic circuit. But how did it travel from the clock to your face? If you could watch with perfect instruments, you might see something wonderful and strange. Each photon doesn't take just one path from the clock to your eyelid. In some mysterious way, it explores every possible path at the same time. It bounces off your ceiling, ricochets from your walls, curves through the air, and travels in perfectly straight lines. All simultaneously. All paths exist together until the photon finally arrives at your eye. Only then does the photon choose. Only at the moment of arrival does it collapse all its possible journeys into one actual path. The wave of possibilities becomes a particle of reality. This is called the path integral, and it's one of the most beautiful ideas in all of physics. Every photon is an explorer, touching every possible route before settling on where it actually goes. The light that traveled from distant stars to reach Earth tonight followed this same principle. Starlight that left the sun 8 minutes ago explored billions of possible paths through space. The ancient light from galaxies millions of years old sampled every conceivable route across the cosmos before finally arriving at your window. You are connected to the universe through these quantum messengers. The light touching your skin right now links you to the birth of stars, the dance of planets, and the glow of cities across the world. But the mystery deepens. Scientists have discovered that light doesn't just act like particles sometimes and waves other times. In the deepest sense, light is neither a particle nor a wave. It is something more fundamental, something that can appear as either, depending on the questions you ask. This something has no name in ordinary language because it exists beyond ordinary experience. Quantum physicists use mathematical equations to describe it, but the mathematics points to a reality stranger and more beautiful than equations can capture. When you dream tonight, your mind will do something similar to what light does. Your thoughts will explore many possibilities at once. In dreams, you could be in multiple places simultaneously. You could be different ages, different people, different versions of yourself. Perhaps consciousness and quantum mechanics share something deep and mysterious. Perhaps the same principles that allow light to be both particle and wave also allow your mind to explore the impossible landscapes of dreams. The photons dancing around you in the darkness carry this quantum strangeness in their very nature. They remind you that reality is far more mysterious, far more magical than it appears on the surface. As you settle deeper into rest, let yourself wonder about the electrons in your own body, those tiny companions that make your thoughts and heartbeat possible. Feel the weight of your body against your bed. Notice how solid and real everything seems. Your pillow cradles your head. The blanket rests heavy across your chest. The mattress holds you steady and secure. This feeling of solidity is one of life's most comforting illusions. If you could peer inside the atoms that make up your pillow, your blanket, even your own body, you would discover something extraordinary. You would find that solid matter is mostly empty space. Vast, silent, beautiful emptiness. Imagine an atom as large as a football stadium. In the very center sits the nucleus, no bigger than a marble. That tiny marble contains nearly all the atom's weight. But where are the electrons that orbit this central core? They are everywhere and nowhere, dancing in the stadium's enormous emptiness. In your everyday world, things have clear boundaries. Your hand ends where the air begins. Your coffee mug sits separate from the table. Everything occupies its own definite space. But electrons live by different rules. They don't orbit the nucleus like planets around the sun, following neat, predictable paths. Instead, they exist as clouds of possibility. Fuzzy, shifting, dreamlike clouds that spread throughout the atom's vast interior. Scientists call these clouds orbitals, but you can think of them as electron dreams. Each electron dreams of being in many places at once. It whispers through the emptiness, sampling every possible location before settling anywhere specific. Right now, as you breathe quietly in the darkness, trillions of electrons in your lungs are flowing like gentle water. They don't have sharp edges or definite positions. They exist as soft probability clouds, each one spread across space like morning mist across a meadow. When you inhale, oxygen molecules enter your body. But these molecules aren't solid little balls bumping around inside you. They are quantum creatures, their electrons interweaving in an intricate dance of possibility. Your body knows how to speak this quantum language perfectly. Every time your heart beats, electrons flow through the muscles in coordinated waves. They don't march in straight lines like soldiers. They ripple through your cells like music, creating the electrical patterns that keep you alive. The calcium in your bones, the iron in your blood, the carbon that forms your DNA. All of it exists in this strange, beautiful state between solid and liquid, between here and there, between real and possible. This is why chemistry works at all. When atoms bond together to form molecules, their electron clouds overlap and merge. Two hydrogen atoms approach an oxygen atom to create water. But they don't simply stick together like building blocks. Instead, their electron clouds flow into new shapes, creating entirely new patterns of possibility. The electrons forget which atom they originally belonged to. They become citizens of the whole molecule, flowing freely through their new, expanded home. This is happening in your body right now, millions of times per second. Electrons are constantly reshaping themselves, flowing between atoms, creating the chemical reactions that power your thoughts and dreams. In the quantum world, ownership becomes meaningless. Boundaries dissolve. The sharp divisions of everyday life soften into something more fluid and generous. Scientists discovered this strangeness gradually, through careful experiments that seemed almost impossible to believe. They found that if you try to measure an electron's exact position, it becomes more uncertain about its speed. If you pin down its speed precisely, its position becomes completely fuzzy. The electron refuses to be fully known in the way familiar objects can be known. This isn't because measuring tools aren't good enough. It's because electrons fundamentally exist in a state of gentle uncertainty. They are most themselves when they remain a little mysterious. Perhaps this is why living things feel so alive. The matter in your body never quite settles into fixed, dead patterns. It maintains this quantum fluidity, this constant dancing between possibilities. Your brain contains roughly 86 billion neurons, each one a complex quantum system. The electrons in these cells don't simply carry electrical signals like wires in a machine. They create patterns of possibility that somehow give rise to your thoughts, your memories, your sense of who you are. No one fully understands how this happens. The leap from quantum mechanics to consciousness remains one of the deepest mysteries in science. But perhaps that's exactly as it should be. Perhaps some questions are more beautiful when they remain open. As you rest here in the quiet darkness, your body's atoms are engaged in their eternal quantum dance. The boundary between you and the air around you isn't as clear as it seems. Your electron clouds extend slightly beyond your skin, mixing gently with the electron clouds of the oxygen and nitrogen molecules nearby. You are not separate from the world around you. At the quantum level, you are part of a continuous field of possibility that extends through your room, your house, your neighborhood, and beyond. The wooden furniture around you, the metal springs in your mattress, the cotton in your sheets, all of it participates in this same quantum flowing. All of it exists in the same state of beautiful uncertainty. Matter, you see, is not really a thing at all. It is a process, a constant becoming, a never-ending dance of electrons creating and recreating the patterns we experience as solid reality. When you were a child, you might have wondered what you would find if you could cut something in half, then cut the pieces in half again, continuing until you reach the smallest possible piece. Now you know the answer. You would find not a tiny solid ball, but a cloud of possibility, a whisper of maybe, a quantum dream that dances between real and unreal, creating the illusion of solidity through its very uncertainty. This is the secret that matter has been keeping since the beginning of time. This is why roses can grow from soil, why your body can heal from wounds, why life can emerge from lifeless elements. Everything flows. Everything connects. Everything participates in the same cosmic dance of possibility. But there's something even stranger about this quantum world, something that makes it more mysterious still. The dance changes when someone is watching. Picture a butterfly resting on a flower in your garden. To watch it closely, you must move carefully. Even your gentle footsteps might cause it to flutter away. Your presence changes the very scene you came to observe. In the quantum world, this effect becomes even more profound and mysterious. When scientists first built instruments delicate enough to observe individual atoms and electrons, they discovered something that challenged everything they thought they knew about reality. The simple act of looking changed what was there to be seen. Imagine you're trying to find a friend in a completely dark room. You reach out carefully with your hands, feeling through the space around you. But each time your fingers touch something, you move it slightly. Your search changes the very arrangement you're trying to discover. This is what happens when scientists try to observe quantum particles. To see an electron, they must shine light on it. But light carries energy, and that energy gently pushes the electron, changing its position or speed. The measurement itself becomes part of the story. At first, researchers thought this was simply a technical problem. Build better instruments, they said. Use gentler methods. Find a way to look without disturbing. But deeper investigation revealed something far more extraordinary. The disturbance wasn't just an inconvenience to be solved. It was a fundamental feature of reality itself. In the quantum realm, the observer and the observed are not separate. They form a single, interconnected system. The electron doesn't have definite properties waiting to be discovered. Instead, it exists in a state of pure potential until the moment of observation creates specific properties. Think of it like this. Before you look in your closet, your clothes don't have definite positions. They exist in a superposition of all possible arrangements. Only when you open the door and look does the universe choose one specific arrangement to show you. This sounds impossible, and it felt impossible to the scientists who first encountered it. Albert Einstein himself struggled with this idea for decades. He famously said that God does not play dice with the universe, expressing his discomfort with quantum uncertainty. But experiments have confirmed this strange truth again and again. Reality seems to be fundamentally interactive. It requires the dance between observer and observed to become fully real. In laboratories around the world, researchers conduct delicate experiments to explore this mystery. They work in rooms so quiet you could hear a pin drop on carpet. Their instruments are isolated from every possible vibration, cooled to temperatures colder than deep space. Yet, even in these pristine conditions, the observer effect remains. It's not about clumsy humans bumping into delicate equipment. It's about something much deeper in the fabric of existence itself. Consider how this might apply to your own experience right now. As you lie in bed, aware of your breathing, your awareness itself might be gently shaping the quantum processes in your brain. The electrons firing between your neurons exist in probability clouds until your consciousness somehow selects specific patterns. Perhaps attention is more powerful than we imagine. Perhaps the simple act of noticing something changes it in ways we're only beginning to understand. Scientists have discovered that quantum systems can exist in multiple states simultaneously until something forces them to choose. A particle can spin clockwise and counterclockwise at the same time. It can be in two different locations at once. It can have multiple energies simultaneously. But the moment you try to measure any of these properties, the system collapses into a single definite state. It's as if reality were a vast symphony of possibilities, and observation is like asking the orchestra to play just one note. This collapse happens faster than thought, faster than light, faster than anything else in the universe. One moment, infinite possibilities. The next moment, one actual result. What triggers this collapse? The answer remains beautifully mysterious. Some scientists believe it happens when a quantum system interacts with something large and complex, like a measuring instrument. The delicate quantum states become entangled with billions of atoms in the detector, and this interaction forces a choice. Others suggest that consciousness itself plays a role. They wonder if awareness, attention, and observation are more fundamental to reality than we ever supposed. Still others propose that all possibilities remain equally real, branching into parallel universes each time a quantum choice occurs. In this view, observation doesn't collapse possibilities, but simply selects which branch of reality we experience. No one knows which interpretation is correct. Perhaps they all contain pieces of a truth too large for any single explanation. What we do know is that the universe seems to resist being fully observed. It maintains an essential privacy, a core of mystery that no instrument can penetrate completely. The more precisely you try to pin down a quantum system, the more it slips away into uncertainty. This isn't a failure of science. It's a feature of existence itself. Reality seems to be designed with built-in limits on how much any single observer can know at once. There's something humble and beautiful about this. It suggests that the universe will always be larger than our understanding, deeper than our measurements, more mysterious than our theories. As you rest here in the gentle darkness, you are participating in this same dance between observer and observed. Your body is a quantum system of unimaginable complexity. Trillions of particles are constantly making quantum choices that shape your thoughts, your feelings, your dreams. Perhaps your consciousness is like a gentle spotlight moving through the vast quantum possibilities of your brain. Where your attention goes, reality crystallizes from the fog of potential into the clarity of experience. Your heartbeat, steady and calm, might be stabilizing quantum rhythms throughout your body. Your slow, peaceful breathing might be helping quantum systems in your cells choose states that promote rest and healing. The boundary between your inner awareness and the quantum dance happening within you grows soft and permeable. You are not separate from the quantum world. You are an active participant in its eternal creativity. Even now, as these ideas settle gently into your mind, they might be influencing the quantum processes that will shape your dreams tonight. In laboratories around the world, sensitive instruments are detecting quantum effects that seem impossible according to everyday logic. Particles are being found in two places at once, spinning in multiple directions simultaneously, affecting each other across vast distances. But perhaps the most extraordinary quantum effect of all is how particles remember when they have been observed, even when no trace of that observation should remain. Rest your hand gently on your chest and feel your heartbeat. Each pulse sends waves of pressure through your body, rippling outward like circles spreading across still water. These waves carry information about your life, your health, your peaceful state of rest. Now imagine that these waves could suddenly become individual messengers, each one carrying a tiny piece of your heartbeat to different parts of your body. This transformation from wave to particle is exactly what light does every moment of your life. When morning sunlight streams through your window, it travels toward you as waves. These waves spread out like gentle ripples, filling space with warmth and brightness. They curve around obstacles, bend through your window glass, and create the soft patterns of light and shadow that dance across your walls. But the moment that sunlight touches your skin, something magical happens. The waves transform into individual particles of energy called photons. Each photon carries just enough energy to warm a tiny spot on your arm or trigger a single cell in your eye. This isn't two different types of light. This is the same light choosing different ways to exist, depending on what the situation requires. Picture waves rolling toward a beach. From far away, you see smooth, continuous motion. Water rises and falls in graceful curves that seem to go on forever. But when each wave finally reaches the shore, it breaks into countless individual droplets, each one splashing against the sand separately. Light behaves in a remarkably similar way. When scientists first discovered this dual nature, they couldn't quite believe it. How could something be both a wave and a particle? How could light spread out like ripples on a pond and also arrive in tiny, countable packets? The answer lies in one of nature's most beautiful principles. Light is neither purely wave nor purely particle. It is something deeper and more mysterious that can express itself as either, depending on how you encounter it. Think about music for a moment. When your favorite song plays softly in the background, the sound waves flow continuously through the air. They spread out smoothly, filling your room with melody and rhythm. But when those same sound waves reach your ears, your brain processes them as individual notes, separate beats, distinct musical moments. The music doesn't change from wave to particle the way light does, but the principle is similar. The same phenomenon can be experienced in different ways depending on how it interacts with its surroundings. Light takes this flexibility much further. When light passes through two narrow slits in a barrier, it creates an interference pattern on the wall beyond. Bright and dark stripes appear, exactly like the pattern you'd see if water wave passed through two openings and overlapped on the far side. This proves that light travels as waves. The waves from both slits spread out and meet each other, sometimes adding together to create bright spots, sometimes canceling out to create darkness. But here comes the mystery that puzzled scientists for decades. If you dim the light until only one photon at a time passes through the slits, you might expect the wave pattern to disappear. After all, how can a single particle interfere with itself? Yet the stripe pattern remains. Each individual photon somehow knows about both slits, even though it can only pass through one of them. Each particle behaves like a wave that explores all possible paths simultaneously. It's as if each photon asks itself, how shall I travel today? Shall I spread out like morning mist, sampling every possible route? Or shall I arrive like a raindrop, concentrated and precise? The answer depends on what's waiting at the destination. When light encounters something that can absorb its energy, like the cells in your eye or a leaf on a tree, it chooses to arrive as individual photons. Each photon delivers its energy package to exactly one electron, causing precisely the right chemical reaction to trigger vision or photosynthesis. But when light travels through empty space or passes through transparent materials, it often chooses to spread out as waves. This allows it to carry information efficiently across vast distances and to create the interference patterns that make holography and many other technologies possible. The choice isn't random. Light seems to know exactly what form will be most useful in each situation. Right now, light from your bedside clock is making this choice millions of times per second. Photons emerge from the digital display as particles, each one carrying a specific amount of energy. But as they travel through the air toward your eyes, they spread out like waves, exploring multiple paths through your room. When they finally reach your closed eyelids, they return to particle form, each one depositing its tiny burst of energy into the atoms of your skin. This constant transformation happens so smoothly that you never notice it. Light shifts between wave and particle nature as easily as water flows around stones in a stream. Scientists have learned to work with both aspects of light's personality. Lasers use light's wave properties to create perfectly coordinated beams. Solar panels rely on light's particle nature to knock electrons free and generate electricity. Your own body uses both aspects as well. The wave nature of light allows your eyes to focus images clearly. The particle nature provides the precise energy needed to trigger the chemical reactions that let you see colors and shapes. Even more remarkably, light remembers its wave nature even when behaving as particles. Each photon carries information about all the paths it might have taken, like a traveler who somehow recalls every road not taken. This memory allows light to create quantum interference effects that seem impossible from a particle perspective, but make perfect sense when you remember that each particle was once a wave that experienced all possibilities simultaneously. As you drift deeper towards sleep, consider how your dreams might work in a similar way, flowing between different forms of awareness like light flowing between waves and particles. Close your eyes and imagine your childhood bedroom. Picture yourself as a young child, lying in that familiar bed on a quiet night. You could hear sound from other rooms, footsteps in a hallway, distant voices from downstairs. In your imagination, you existed simultaneously in your bed and in those other rooms. Part of you wondered what was happening in the kitchen. Part of you followed the sounds upstairs. Part of you remained safely tucked under your covers. This is exactly how electrons exist around the nucleus of every atom in your body. Traditional pictures show electrons as tiny balls orbiting the nucleus like planets around the sun. These images are comforting and easy to understand, but they tell only a small part of the electron's true story. In reality, electrons don't follow neat circular paths. Instead, they exist as clouds of possibility, simultaneously present in many locations around their atomic home. They are everywhere and nowhere until something forces them to choose a specific place to be found. Imagine a ghost that can walk through walls, float through ceilings, and exist in multiple rooms at once. The ghost doesn't take a specific path from kitchen to bedroom. Instead, it simply exists throughout the entire house simultaneously, a whisper of presence in every corner. This is the closest everyday analogy to how electrons actually behave. Scientists call these ghostly electron clouds orbitals. But you can think of them as probability maps, showing all the places an electron might be discovered if you looked for it. Some orbitals are spherical clouds surrounding the nucleus like soft, fuzzy bubbles. Others have more complex shapes, like figure eights stretched through three-dimensional space or dumbbells twisted into intricate patterns. Each orbital represents a different energy level, a different way the electron can exist around its nucleus. An electron can occupy the simple, spherical ground floor orbital, or it can absorb energy and move to a higher level orbital with a more complex shape. But here's the remarkable thing. The electron doesn't travel from one orbital to another. It doesn't take any path at all. It simply disappears from the first orbital and appears in the second, instantly and completely. This quantum leap happens faster than anything else in the universe. One moment, the electron exists as a cloud around the ground level. The next moment, it exists as a completely different cloud at a higher energy level. No journey, no transition period, no in-between state. It's like a person who vanishes from their living room and instantly materializes in their attic, without ever walking up the stairs, without ever existing on the steps or in the hallway. They simply are downstairs, then they are upstairs, with no time spent traveling between. Right now, as you rest peacefully, electrons throughout your body are making these quantum leaps millions of times per second. In your brain cells, electrons jump between energy levels to create the electrical signals that carry your thoughts. In your heart muscle, electron transitions power the contractions that keep your blood flowing. Each leap releases or absorbs a specific amount of energy, like a musical note with a precise pitch. The calcium atoms in your bones play one set of quantum notes. The iron atoms in your blood play a different set. The carbon atoms in your DNA contribute their own unique frequencies. Together, all these quantum leaps create a symphony of energy that is uniquely yours. No other person has exactly the same quantum signature, the same electronic music playing in their atoms. But the mystery of electron behavior goes even deeper. When an electron exists in its orbital cloud, it doesn't simply hide its true position from us. It genuinely doesn't have a definite position. Position, in the ordinary sense, becomes meaningless at this scale. Think about a sound echoing in a large cathedral. Where exactly is the echo? It fills the entire space, reverberating off every wall, existing throughout the vast interior. You can't point to one spot and say, there is the echo. The echo is the pattern of sound distributed through the whole cathedral. Electrons are similar. They are patterns of possibility distributed through their orbitals. They don't hide somewhere within the cloud. They're the cloud. This seems impossible from our everyday perspective. How can something exist everywhere at once? How can an electron be a spread-out cloud rather than a tiny ball? The answer lies in the quantum nature of reality itself. At the atomic scale, the sharp distinctions of the everyday world dissolve. The boundary between here and there, between particle and wave, between real and possible, becomes soft and permeable. Your body contains roughly 7 billion atoms. In each one, electrons exist as these ghostly probability clouds. They flow through their orbitals like music through a concert hall, creating the chemical bonds that hold your molecules together. When two atoms form a chemical bond, their electron clouds merge and overlap. The electrons stop belonging to individual atoms and become shared citizens of the new molecule. They create new orbital patterns that span both atomic nuclei, binding them together with quantum threads of possibility. This is happening continuously throughout your body. Electrons are constantly reshaping themselves, flowing between atoms, creating and breaking the molecular bonds that enable life itself. The water in your cells, the proteins in your muscles, the DNA in every nucleus. All of it is held together by electrons that exist not as particles, but as shared clouds of quantum possibility. Even more remarkable, Electrons can tunnel through barriers that should be impossible to cross. If an electron encounters an energy barrier too high for it to climb over, it can sometimes appear on the other side anyway, as if it walked through a solid wall. This quantum tunneling happens because the electron's wave-like nature allows it to leak through barriers, to exist partially on both sides simultaneously until it chooses which side to call home. In your body right now, electrons are tunneling through cellular membranes, enabling chemical reactions that would be impossible in a purely classical world. These quantum effects help explain how enzymes work so efficiently, how your nervous system processes information so quickly, how life can exist at all. Perhaps consciousness itself depends on quantum effects in the electrons of your brain cells. Some scientists propose that the strange, non-local properties of quantum systems might help explain how separate neurons can work together to create unified thoughts and experiences. As you settle deeper into rest, your brain waves slow down, changing the quantum patterns in your neurons. Electrons throughout your nervous system are shifting into new configurations that promote deep, restorative sleep. They move like gentle spirits through the neural networks of your dreams, carrying messages between memory and imagination, between the day's experiences and tomorrow's possibilities. But even as they flow through these complex patterns, electrons maintain their fundamental mystery, their refusal to be fully pinned down or completely understood. Perhaps this quantum uncertainty is not a bug, but a feature, allowing life and consciousness to emerge from the interplay of possibility and actuality, the eternal dance between what might be and what finally comes to pass. Think about tomorrow morning when you wake up. You don't know the exact moment your eyes will open. You don't know which dream will be your last before consciousness returns. Yet you feel confident that morning will come, that you will wake, that a new day will begin. This gentle confidence in uncertain timing is exactly how the quantum world operates. In your everyday experience, things either happen or they don't. The coin lands heads or tails. The light switches on or off. You're either awake or asleep. Reality seems to make clear choices between definite alternatives. But in the quantum realm, certainty dissolves into something softer and more beautiful. Instead of definite outcomes, there are probability clouds. Instead of yes or no, there are gentle percentages floating between 0 and 100. Imagine a garden where flowers exist in various stages of blooming simultaneously. Some buds hover at 10% open. Others rest at 40%. A few shimmer at 75%, almost ready to reveal their full beauty. None are completely closed, none fully open, all suspended in states of gentle becoming. This is how quantum particles exist before measurement forces them to choose definite properties. An electron doesn't have a specific location. Instead, it has a probability of being found in various places. Scientists can calculate that there's a 30% chance of finding it here, a 50% chance of finding it there, a 20% chance of discovering it somewhere else entirely. These probabilities aren't just measures of our ignorance. They're not placeholders for hidden information we haven't discovered yet. The probabilities are the reality. The electron literally exists in a superposition of all these possible locations, each one weighted by its probability. It's like being homesick for multiple places at once, feeling drawn to your childhood bedroom with 30% of your heart, to your current home with 50%, and to some distant dreamed-of place with the remaining 20%. You exist in all these emotional locations simultaneously until something forces you to choose where to direct your full attention. Right now, quantum systems throughout your body are existing in these probability states. The electrons in your brain cells hover between different energy levels. Some have a high probability of jumping to excited states. Others rest comfortably in lower energy configurations. These quantum probabilities are constantly shifting, like subtle weather patterns in the microscopic landscape of your cells. Temperature changes the odds. Chemical interactions alter the percentages. Your thoughts and emotions might even influence the probability distributions in your neural networks. Scientists describe these probability patterns using mathematical equations that look almost like poetry. Wave functions rise and fall like musical notes, creating interference patterns that determine where particles are likely to be found. The mathematics predicts probability waves that spread through space like ripples on a pond. Where two waves meet and reinforce each other, the probability increases. Where they cancel out, the probability drops to zero. These aren't waves of water or air. They're waves of pure possibility, mathematical descriptions of all the ways reality might unfold. When you were young, you might have shaken a snow globe and watched the white flakes settle slowly into new patterns. Each shake created a different arrangement, but you could never predict exactly where each flake would land. You could only observe the general distribution, the overall beauty of the settling snow. Quantum probability works similarly. You can't predict exactly what will happen to any individual particle, but you can calculate the beautiful statistical patterns that emerge when you observe many particles over time. The strange thing is that these probability patterns are incredibly precise. Scientists can predict with extraordinary accuracy how many electrons will be found in various locations, even though they can't say anything definite about any single electron. It's like knowing exactly how many people will visit a park on a sunny weekend, while having no idea which specific individuals will show up. The collective behavior follows reliable patterns, even though individual choices remain mysterious. This mathematical poetry of probability has practical consequences that touch your life every day. The colors you see exist because electrons and atoms have specific probabilities of jumping between energy levels. Each jump releases light with a precise frequency, creating the rich palette of the world around you. The chemistry that keeps you alive depends on these quantum probabilities. Enzymes work because electrons have just the right odds of tunneling through energy barriers. DNA maintains its structure because quantum mechanics gives molecular bonds exactly the right probability distributions to be stable yet flexible. Even the sun's light reaches you because of quantum probability. Deep in the sun's core, protons overcome enormous energy barriers through quantum tunneling effects that classical physics says should be impossible. The probability is tiny for any single proton, but with billions of attempts every second, enough succeed to keep the sun burning. As you breathe quietly in the darkness, oxygen molecules enter your lungs with probability clouds surrounding each atom. These clouds determine how likely the oxygen is to bind with the iron in your red blood cells, how probable it is to participate in the cellular respiration that powers your dreams. There's something deeply peaceful about this quantum uncertainty. It means that the future isn't fixed, isn't predetermined down to the smallest detail. Instead, it exists as a garden of possibilities, each one with its own gentle probability of blooming into actuality. Your tomorrow morning exists right now as a superposition of probability waves. Maybe you'll wake at sunrise, maybe later. Maybe you'll remember your dreams. Maybe they'll fade like mist. All these futures coexist in the quantum realm of possibility until the moment of waking collapses them into a single experienced reality. The mathematics of quantum mechanics suggest that consciousness itself might play a role in this collapse from probability to actuality. Perhaps your awareness is what tips the scales, what transforms the gentle maybe of quantum superposition into the definite yes of lived experience. As you drift deeper towards sleep, your brain waves are changing the probability patterns in your neurons, preparing them for the different quantum configurations that accompany dreams and rest. But there's another aspect of quantum uncertainty that goes even deeper, suggesting that nature herself has fundamental limits on how much can be known simultaneously about any system. Picture yourself trying to photograph a hummingbird in flight. If you use a fast shutter speed to capture exactly where the bird is at one instant, the image freezes its position perfectly but tells you nothing about how fast it was moving. If you slow the shutter to show the graceful blur of motion, you capture the bird's speed but lose the precise details of its location. This everyday challenge hints at something much deeper woven into the fabric of reality itself. In the 1920s, a young German physicist named Werner Heisenberg discovered that nature has built-in limits on how much we can know about any quantum system at once. The more precisely you try to pin down a particle's exact location, the less you can know about how fast it's moving. The more exactly you measure its speed and direction, the fuzzier its position becomes. This isn't a problem with measuring instruments or human limitations. It's a fundamental feature of existence itself. Reality seems to resist being completely known all at once. Imagine trying to observe a shy forest animal that becomes more elusive the harder you look for it. The brighter you shine your flashlight to see it clearly, the more it retreats into shadows. The quieter you become to avoid disturbing it, the less you can see of its exact location. Electrons behave similarly with light and measurement tools. To find an electron's position precisely, you must shine high-energy light on it. But this light carries so much energy that it kicks the electron in unpredictable directions, completely scrambling your knowledge of its motion. To measure the electron's speed accurately, you need gentle, low-energy light that won't disturb its motion. But this gentle light has such long wavelengths that it can't pinpoint the electron's location precisely. Nature has set up this cosmic trade-off where perfect knowledge of everything becomes impossible. There's something almost playful about it, as if the universe enjoys keeping a few secrets. This principle extends beyond just position and speed. The more precisely you know when something happens, the less you can know about its energy. The more exactly you pin down a particle's energy, the fuzzier the timing becomes. It's like listening to music in a noisy room. If you focus intently on hearing one specific note with perfect clarity, you lose track of the rhythm and timing of the whole song. If you pay attention to the beat and tempo, individual notes blur together into harmony. Your own experience offers gentle examples of this principle. When you're completely absorbed in the present moment, deeply focused on exactly where you are right now, you often lose track of time passing. When you're very aware of time, of schedules and duration, your attention to your immediate surroundings often softens. Perhaps consciousness itself follows similar patterns. The more precisely you try to analyze your thoughts, the more their natural flow changes. The more you observe your emotions directly, the more they shift and transform under your attention. Right now, as you rest in the peaceful darkness, electrons throughout your body are living within these uncertainty limits. None of them has a perfectly defined position and speed simultaneously. They exist in clouds of complementary uncertainties, their locations and movements forever intertwined in quantum embrace. This might sound limiting, but uncertainty actually enables the richness of the world around you. If electrons had perfectly defined positions and speeds at all times, they would follow completely predictable paths like tiny billiard balls. Chemistry would be impossible. Life would be impossible. The universe would be a clockwork machine with no room for creativity or change. Instead, uncertainty gives electrons the freedom to exist in probability clouds, to tunnel through barriers, to participate in the chemical bonds that make complex molecules possible. Uncertainty is what allows atoms to share electrons and form the partnerships that create everything from water to DNA. The uncertainty principle ensures that atoms remain stable while staying dynamic. Electrons can't collapse into the nucleus because their position uncertainty keeps them spread out in orbitals. Yet they can still jump between energy levels, enabling the chemistry of life. In your brain right now, neural signals depend on this quantum uncertainty. Ions flow through cell membranes partly because their positions and energies remain slightly fuzzy, allowing them to tunnel through molecular channels that would be impassable in a completely predictable world. There's something beautiful about accepting this fundamental mystery at the heart of reality. It suggests that the universe values privacy, that some things are meant to remain partially hidden, partially unknown. Ancient wisdom traditions often speak of the importance of embracing mystery, of finding peace with not knowing everything. The uncertainty principle shows that nature herself shares this philosophy. Reality is built on a foundation of gentle unknowing. Scientists have learned to work with uncertainty rather than against it. They use probability mathematics to predict the likely outcomes of quantum experiments. They design technologies that harness uncertainty effects. They find beauty in the patterns that emerge from fundamental unpredictability. The laser that reads information from a CD player, the transistors in your phone, the solar panels that convert sunlight to electricity. All of these technologies depend on quantum uncertainty effects. They work because engineers learn to dance with mystery rather than trying to eliminate it. As you breathe slowly and peacefully, you're participating in this cosmic dance of uncertainty. The oxygen molecules entering your lungs don't have perfectly defined trajectories. They explore probability clouds of possible paths, somehow finding their way to exactly where your body needs them. Your heartbeat arises from electrical signals that depend on quantum uncertainty in your heart muscle cells. The timing isn't perfectly predictable, yet it maintains the steady rhythm that has sustained you throughout your life. Even your dreams tonight will emerge from neural networks governed by quantum uncertainty. Your sleeping brain will explore probability landscapes of memory and imagination, creating stories that surprise even you with their unexpected connections and emotions. Perhaps the uncertainty principle offers a kind of cosmic permission to not have everything figured out. It reminds you that mystery isn't a problem to be solved, but a feature to be appreciated. In relationships, trying to know everything about someone often pushes them away. In creativity, demanding complete certainty often blocks inspiration. In living, insisting on perfect control often prevents growth and joy. Nature seems to understand something profound about the value of leaving room for the unknown, for the uncontrolled, for the gently mysterious. As you settle deeper into rest, you join the electrons in your body in their comfortable dance with uncertainty, trusting that some things are more beautiful when they remain partially hidden. But uncertainty is just one aspect of an even stranger quantum phenomenon, where particles seem to exist in multiple states simultaneously until the moment observation forces them to choose. In the quiet moment before sleep takes hold, your mind hovers between wakefulness and dreams. You're not quite awake, not yet asleep. Instead, you exist in a peaceful in-between state where both possibilities coexist gently within your consciousness. This liminal space mirrors one of the most beautiful and mysterious aspects of quantum reality. In the quantum world, particles don't have to choose between different states the way objects do in your everyday experience. A coin must be either heads or tails. A light switch is either on or off. A door stands either open or closed. But quantum particles can exist in superposition, simultaneously embodying multiple contradictory states until something forces them to make a choice. Imagine a musical chord played softly on a piano. The chord contains multiple notes at once. Your ear doesn't hear just one note or another. It hears all the notes blending together in harmony, each one contributing to the overall sound while maintaining its individual frequency. Quantum superposition works similarly. A particle can spin clockwise and counterclockwise simultaneously. It can have high energy and low energy at the same time. It can exist in multiple locations at once, like a gentle presence that fills several rooms of a house simultaneously. This isn't just a limitation of our knowledge. The particle doesn't secretly have a definite state that we simply haven't discovered yet. It genuinely exists in all these states simultaneously, like a chord that truly contains all its notes at once. Scientists first encountered superposition in the behavior of individual atoms. When they cooled atoms to incredibly low temperatures and isolated them from all outside disturbances, they found that electrons could occupy multiple energy levels at the same time. Picture a person who could simultaneously live on the ground floor and third floor of a building, paying rent for both apartments, receiving mail at both addresses, somehow being fully present in multiple places at once. This describes how electrons behave in their atomic homes. The electron doesn't split into pieces. It doesn't rapidly jump back and forth between levels. It exists as a single particle that somehow includes multiple states within itself, like a note that contains several frequencies simultaneously. Right now, quantum systems throughout your body are maintaining delicate superposition states. Electrons in your brain cells hover between different energy configurations. Some exist simultaneously in excited and relaxed states, contributing to the electrical patterns that enable your thoughts and dreams. The calcium ions in your neurons can exist in superposition states that allow them to influence multiple cellular processes at once. This quantum flexibility might help explain how your brain can process information so efficiently, how millions of neurons can coordinate their activity to create unified conscious experience. As you lie here in the peaceful darkness, photons of light are streaming through your closed eyelids in superposition states. Each photon simultaneously follows multiple paths from various light sources to your eye, exploring every possible route through your room before finally arriving. Only when the photon interacts with your retina does it collapse from its superposition of all possible paths into one actual trajectory. The quantum chord of possibilities becomes a single node of experienced light. This collapse from superposition to definite state happens everywhere in nature, billions of times per second. It's like an orchestra where every instrument plays multiple notes simultaneously until a conductor's baton chooses which single note each instrument will finally sound. But what acts as the conductor in quantum systems? What causes the collapse from many possibilities to one actuality? Scientists still debate this profound question. Some believe that interaction with large, complex systems causes collapse. When a quantum particle encounters billions of atoms in a measuring instrument, the delicate superposition state becomes entangled with too many other systems to maintain its coherence. Others propose that consciousness itself plays a role. Perhaps awareness, attention, and observation are what tip the scales, transforming quantum superposition into classical reality. Still others suggest that collapse never really happens. Instead, all possible outcomes remain equally real, branching into parallel universes. In this view, superposition never ends, but simply becomes too complex for any single observer to perceive all branches simultaneously. Whatever the mechanism, superposition creates the foundation for quantum technologies that seem almost magical. Quantum computers can explore multiple solutions to problems simultaneously, like students who can take every possible path through a maze at once. Quantum sensors can measure magnetic fields and gravitational forces with impossible precision because they use superposition states that respond to the tiniest environmental changes. Even biological systems might harness superposition for enhanced efficiency. Some scientists believe that photosynthesis works so well because chlorophyll molecules use quantum superposition to explore multiple energy transfer pathways simultaneously, always finding the most efficient route. Birds might navigate using quantum superposition in specialized cells that can simultaneously detect multiple orientations of Earth's magnetic field. Their quantum compass exists in superposition until the bird's brain collapses it into a single directional reading. There's something deeply peaceful about the concept of superposition. It suggests that before choices are made, all possibilities can coexist gently within the same system. Conflict and contradiction dissolve into harmony, like musical notes blending into a chord. Perhaps your own decision-making processes echo this quantum principle. Before you commit to a choice, your mind might exist in a superposition of different options. You simultaneously consider multiple possibilities, feeling drawn to several paths at once. Only when you finally decide does your mental superposition collapse into a single course of action. The quantum symphony of maybe becomes the classical melody of yes. Your dreams tonight might emerge from neural superposition states where multiple memory fragments, emotional patterns, and imaginary scenarios exist simultaneously in your sleeping brain. The strange logic of dreams, where you can be multiple people in multiple places with multiple identities, mirrors the quantum logic of superposition. As your consciousness drifts between waking and sleeping, you embody your own form of superposition. You exist simultaneously in the world of sensory experience and the realm of inner imagination, participating in both realities until sleep finally chooses one for you. The quantum particles in your body continue their superposition dance even as you sleep. They maintain the delicate balance of possibilities that keeps your cells functioning, your heart beating, your dreams flowing through the neural networks of your brain. Tomorrow morning, when you wake, countless quantum superpositions will collapse into the classical world of definite experiences. But tonight, you rest within the gentle ambiguity of quantum possibility, surrounded by systems that exist in multiple states simultaneously. The boundary between the quantum world of superposition and the classical world of definite outcomes remains one of science's deepest mysteries, made even more strange by the discovery that particles can remain mysteriously connected across impossible distances. Think of someone you love who lives far away. Even when you're separated by continents, you sometimes feel a mysterious connection to them. You wake up thinking of them on the very day they need support. You feel their joy when something wonderful happens in their life, even before they call to share the news. This sense of invisible connection across vast distances hints at something even more profound that happens in the quantum world. When two particles interact intimately, sharing energy or spinning together in a dance of quantum properties, something remarkable occurs. They become entangled. Forever after, no matter how far apart they travel, they remain mysteriously connected in ways that seem to transcend the normal limits of space and time. Imagine twins who share not just genes, but thoughts and feelings. When something happens to one twin in Tokyo, the other twin in New York instantly experiences the same thing. No signal passes between them. No message travels through space. The connection simply exists, immediate and complete. This is exactly what happens with entangled particles. When scientists measure the spin of one entangled electron, they instantly know the spin of its partner, even if that partner is on the other side of the galaxy. When one particle changes its quantum state, its entangled companion immediately responds, as if they were still touching despite being separated by impossible distances. Einstein called this spooky action at a distance because it troubled him deeply. He believed that nothing could travel faster than light, that no influence could cross space instantaneously. Yet entangled particles seem to communicate with each other at infinite speed. For decades, scientists wondered if the particles were somehow carrying hidden information with them, like secret messages written in quantum code. Perhaps they agreed on their behavior before separating, following a predetermined script that only appeared to show instantaneous connection. But careful experiments have proven that the connection is real and immediate. The particles don't carry hidden instructions. They genuinely remain linked in a single quantum system that spans any distance. Right now, there are entangled particles in your body that were created in the nuclear reactions deep inside ancient stars. Some of these particles might be entangled with others scattered across the universe, maintaining their cosmic connections across billions of years and countless light years. The calcium in your bones, the iron in your blood, the carbon in your DNA. All of these elements were forged in stellar cores where particles dance together in intimate quantum relationships before being scattered into space by supernovas. Some of those ancient quantum partnerships might persist even now, connecting pieces of your physical being to distant stars and galaxies in ways that science is only beginning to explore. Entanglement reveals something profound about the nature of reality itself. At the deepest level, the universe isn't made of separate objects bumping into each other like billiard balls. Instead, it's a unified whole where distant parts remain intimately connected through invisible quantum threads. When you look up at the night sky, you're not seeing separate, isolated stars. You're looking at a cosmic web of quantum connections that links everything to everything else in an unbroken network of relationship. This quantum intimacy operates in your own body as well. The electrons in your brain cells can become entangled with each other, creating coordinated patterns that might help explain how separate neurons work together to create unified thoughts and experiences. Perhaps consciousness itself emerges from quantum entanglement between the particles in your nervous system. Your sense of being a single, unified person might arise from trillions of entangled particles working together as one coherent quantum system. Scientists are learning to create and control entanglement for practical purposes. Quantum computers use entangled particles to perform calculations that would take classical computers millions of years. Each entangled pair can exist in superposition, exploring multiple solutions simultaneously while remaining perfectly coordinated with its partners. Quantum communication systems use entanglement to send absolutely secure messages. Any attempt to intercept or eavesdrop on an entangled communication disturbs the delicate quantum connection, immediately alerting both sender and receiver that their privacy has been violated. Even quantum teleportation, though it sounds like science fiction, has been achieved in laboratories. Scientists can transfer the complete quantum state of one particle to another particle far away, using entanglement as the mysterious bridge that carries information across space. The particle itself doesn't travel. Instead, its quantum identity, its essential pattern of properties, appears instantaneously in its entangled partner while disappearing from the original location. As you rest here in the peaceful darkness, quantum entanglement is weaving invisible connections throughout your body and beyond. The atoms in your left hand might be entangled with atoms in your right hand, creating quantum correlations that help coordinate your body's functions. Some particles in your brain might be entangled with particles in your heart, enabling the mysterious communication between thought and emotion that you experience as feelings and intuitions. There's something deeply comforting about entanglement. It suggests that connection is more fundamental than separation, that relationship is built into the very fabric of reality. Even when things appear isolated and alone, they remain part of an invisible web that connects all existence. Perhaps the love you feel for distant friends and family members echoes this quantum truth. Perhaps the sense of connection that transcends physical distance reflects something real and fundamental about how the universe operates at its deepest level. Your dreams tonight might be influenced by entanglement effects in your sleeping brain, creating patterns of meaning and connection that span the quantum networks of your neural pathways. Tomorrow, when you wake, you'll carry within your body countless entangled particles that link you to the cosmos in ways both intimate and infinite. But entanglement is just one aspect of an even more puzzling quantum phenomenon, revealed by a simple experiment that challenges everything we think we know about the nature of reality itself. Imagine standing at the edge of a calm lake, holding two smooth stones. You throw both stones into the water at the same time, creating two sets of ripples that spread outward in perfect circles. Where the ripples meet, they create a beautiful pattern of interference, with some areas where the waves add together to create bigger peaks, and other areas where they cancel out to create stillness. This simple scene contains the essence of one of the most profound experiments in the history of science. More than 200 years ago, scientists shined light through two narrow slits cut into a barrier, just to see what would happen. They expected to see two bright strips on the wall beyond, like shadows cast by the two openings. Instead, they saw something that changed our understanding of reality forever. The light created an interference pattern, just like those ripples on the lake. Bright and dark stripes alternated across the wall, proving that light behaves like waves that can meet, overlap, and interfere with each other. But this was only the beginning of the mystery. As technology improved, scientists were able to dim the light until only one photon at a time passed through the experimental setup. Surely, they thought, a single particle of light could only go through one slit or the other. The wave pattern would disappear. But it didn't. Even when photons traveled one at a time, with long pauses between each one, the same striped pattern slowly emerged on the detection screen. Each individual photon somehow interfered with itself, as if it had passed through both slits simultaneously and met itself on the other side. This seemed impossible. How can a single particle be in two places at once? How can something interfere with itself? The answer revealed something beautiful and strange about the quantum world. Each photon exists in a superposition state, simultaneously exploring both possible paths through the experimental setup. It's not that the photon splits in half. Rather, it maintains its wholeness while somehow experiencing both possibilities at the same time. Think of it like a person who can simultaneously walk through two different doors of the same building, not by splitting into pieces, but by existing in a state where both experiences happen at once. Only when the person reaches the far side of the building do all the possibilities collapse into a single, definite path. But the experiment held an even deeper mystery. When scientists decided to find out which slit each photon actually passed through, they placed detectors at each opening. These detectors were incredibly gentle, designed to observe without disturbing the light's natural behavior. The moment they turned on these detectors, the interference pattern vanished. With detectors watching, each photon behaved like a classical particle, going through one slit or the other, but never both. The wave pattern disappeared completely, replaced by two simple bright spots on the wall, exactly what you'd expect from particles traveling through two separate openings. Turn off the detectors, and the wave pattern returned. Turn them back on, and it disappeared again. The simple act of observation seemed to determine whether light behaved as a wave or as a particle. This wasn't due to the detectors physically disturbing the photons. Even the most delicate possible measurement produced the same result. Somehow, the photons seemed to know whether they were being watched, and they changed their behavior accordingly. Scientists call this the measurement problem, and it touches the very heart of quantum mechanics. It suggests that reality isn't fixed and definite, waiting to be discovered. Instead, reality seems to be created through the interaction between quantum systems and conscious observation. Right now, as you lie quietly in the darkness, countless quantum systems throughout your body are performing their own versions of the double-slit experiment. Electrons in your brain cells exist in superposition states, simultaneously taking multiple paths through the neural networks of your thoughts and dreams. But when these quantum possibilities need to trigger a definite action, like firing a neural signal or contracting a muscle fiber, they collapse from wave-like superposition into particle-like definiteness. Your consciousness might be what causes this collapse, your awareness serving as the detector that transforms quantum possibilities into lived experience. The double-slit experiment reveals something profound about the relationship between mind and matter, between observer and observed. It suggests that the universe is not a collection of separate objects existing independently of observation, but rather a dynamic dance between consciousness and possibility. Perhaps this is why meditation and mindfulness practices feel so powerful. When you pay attention to your breath, your thoughts, or your bodily sensations, you might be participating in this fundamental quantum process, helping to collapse the wave of possibilities into the particle of present moment awareness. The ancient wisdom traditions often speak of the world as a kind of dream or illusion that becomes solid through observation and attention. The double-slit experiment suggests that this poetic metaphor might be closer to literal truth than anyone imagined. Every time you look at something, every time you pay attention to anything in your environment, you might be participating in the creation of reality itself. Your consciousness could be one of the instruments through which the universe chooses which possibilities to make real. Scientists have repeated the double-slit experiment with electrons, atoms, and even large molecules. Every time, the same pattern emerges. Particles interfere with themselves when unobserved, but behave classically when detection is attempted. Some researchers have tried delayed choice experiments, where the decision to observe or not observe is made after the particle has already passed through the slits, but before it hits the detection screen. Remarkably, the particle seems to retroactively choose its behavior based on the future decision about whether to measure it. This suggests that the relationship between observation and reality is even more complex than initially thought, involving connections across time as well as space. As you rest here in the gentle quiet of your room, you are surrounded by quantum systems that exist in delicate superposition states. The air molecules around you, the electrons in your bed sheets, the photons from distant stars streaming through your window. All of them dance between wave and particle nature, waiting for the right kind of observation to collapse them into definite states. Your very presence changes the quantum environment around you. Your body heat, your breathing, your electromagnetic field from your heart and brain. All of these create subtle observations that cause quantum systems to collapse from possibility into actuality. You are not separate from the quantum world. You are an active participant in the eternal conversation between consciousness and cosmos, between what might be and what finally becomes real. The double-slit experiment reminds us that reality is far more participatory, far more interactive than our everyday experience suggests. We don't simply observe a pre-existing world. We help create it through the very act of observation. But even this strange relationship between observation and reality becomes more mysterious when we discover that quantum particles can sometimes pass through barriers that should be completely impossible to cross. Remember the last dream where you walked through a wall as if it were made of mist? In that dream world, solid barriers became permeable, and the impossible felt perfectly natural. You moved through matter as easily as light passes through glass, experiencing a reality where physical laws bent to accommodate wonder. Quantum particles live in this dreamlike reality every moment of their existence. In your everyday world, walls are walls. When you throw a ball at a concrete barrier, it bounces back. The ball doesn't have enough energy to break through, so it returns to you, obeying the reliable laws of classical physics. But in the quantum realm, something magical happens. Particles regularly pass through energy barriers that should completely stop them, appearing on the other side as if they had walked through solid walls. Scientists call this quantum tunneling, and it happens billions of times per second in your own body. Imagine you're hiking in the mountains and come upon a peak too tall and steep to climb over. In the classical world, you would need to find a way around or turn back. But if you were a quantum particle, you could simply tunnel through the mountain and emerge on the other side without ever climbing to the summit. This isn't science fiction. It's one of the most well-documented and practically useful effects in quantum physics. The key lies in the wave-like nature of quantum particles. When an electron approaches an energy barrier, it doesn't behave like a tiny billiard ball that either has enough energy to get over or doesn't. Instead, it exists as a probability wave that can extend beyond the barrier, even when it lacks the energy to classically overcome it. Think of gentle ocean waves meeting a seawall. Most of the wave energy reflects back toward the ocean, but some of the water still manages to splash over and through the barrier, appearing as drops and spray on the protected side. Quantum tunneling works similarly. Most of the particles' probability wave reflect back from the energy barrier, but a portion of the wave extends through and beyond the obstacle, carrying with it the possibility that the particle might be found on the other side. When this happens, the entire particle instantaneously appears beyond the barrier, as if it had magically teleported through solid matter. Right now, quantum tunneling is enabling the chemical reactions that keep you alive. In your cells, protons tunnel through energy barriers that would normally prevent crucial biological processes. Without tunneling, many of the enzymes in your body wouldn't work efficiently enough to sustain life. The DNA in every cell nucleus depends on quantum tunneling for its stability and function. Hydrogen bonds that hold the double helix together are constantly breaking and reforming through tunneling effects. Even the genetic mutations that drive evolution often occur when protons tunnel to unexpected positions in DNA molecules. Your sense of smell relies on quantum tunneling as well. When odor molecules reach your nose, electrons in these molecules tunnel through energy barriers in your olfactory receptors, triggering the neural signals that create your experience of different scents. The sun that warms your face each day shines because of quantum tunneling. Deep in the solar core, protons must overcome enormous electrical barriers to get close enough to fuse into helium. Classically, the sun's core isn't hot enough for fusion to occur. But quantum tunneling allows enough protons to penetrate the barriers, keeping our star burning bright. Electronic devices throughout your home operate thanks to tunneling effects. The transistors in your phone, computer, and digital clocks all depend on electrons tunneling through incredibly thin barriers made of semiconductor materials. Quantum tunneling reveals something profound about the nature of possibility itself. It suggests that barriers in the quantum world aren't absolute walls, but rather obstacles with varying degrees of permeability. Every barrier has what scientists call a tunneling probability. For thick, high-energy barriers, this probability might be incredibly small. But it's never exactly zero. There's always some tiny chance that a particle might appear on the other side, no matter how impossible it seems. This means that even the most solid-appearing matter has an element of ghostliness, a quantum transparency that allows particles to sometimes pass through when conditions are just right. As you breathe peacefully in the darkness, oxygen molecules in your lungs are participating in tunneling processes that help them cross cell membranes and reach your bloodstream. The calcium ions in your bones tunnel through barriers that help maintain the mineral structure that keeps you strong. Even your thoughts and memories might involve tunneling effects. Some neuroscientists propose that quantum tunneling in microtubules within brain cells could contribute to the mysterious processes of consciousness and memory formation. There's something deeply hopeful about quantum tunneling. It suggests that absolute barriers don't exist in nature, that there's always some possibility, however small, for breakthrough and transcendence. Perhaps this is why human creativity often feels like tunneling through impossible obstacles. Artists, inventors, and dreamers regularly find ways through barriers that seem insurmountable, discovering solutions that tunnel around the limitations of conventional thinking. The act of falling asleep itself might involve a kind of consciousness tunneling, where your awareness passes through the energy barrier that normally keeps you alert and focused, emerging on the other side in the dream world where different rules apply. In your dreams tonight, you might experience your own version of quantum tunneling, moving effortlessly through obstacles that would stop you in waking life. Your dreaming mind naturally operates in a quantum-like space where impossibility becomes possibility, where barriers become doorways. The particles in your sleeping brain will continue their eternal dance of tunneling and probability, helping to create the neural patterns that generate your dreams, your rest, your restoration. Even now, as you settle deeper into peaceful stillness, quantum tunneling is occurring throughout your body. Particles are passing through barriers, enabling the biochemical processes that maintain your health and vitality while you sleep. Tomorrow, when you wake, you'll carry within yourself the same quantum capacity for transcending obstacles, for finding ways through barriers that seemed absolute, for discovering that impossibility is often just possibility waiting for the right conditions to unfold. But perhaps the most beautiful aspect of quantum reality is how all these strange effects, when viewed together, begin to weave a picture of existence far more mysterious and interconnected than our everyday experience suggests. Rest here in the gentle darkness and feel the quiet rhythm of your breathing. Each breath connects you to the vast web of existence that scientists have spent centuries trying to understand. Yet the deeper they peer into reality's heart, the more beautiful and mysterious it becomes. Tonight, you have journeyed through the quantum realm, discovering that the solid world around you is mostly empty space filled with probability clouds. You've learned that particles can be waves, that observation changes reality, that distant things remain mysteriously connected across the cosmos. These aren't abstract ideas confined to laboratories and textbooks. They are the living principles that govern every atom in your body, every photon of light touching your skin, every electrical signal flowing through your peaceful, resting brain. You are not separate from quantum reality. You are quantum reality experiencing itself from the inside. The calcium in your bones was forged in the nuclear furnace of dying stars, where quantum tunneling allowed protons to overcome impossible barriers and fuse into heavier elements. The iron in your blood carries the quantum signature of supernovas that exploded billions of years ago, scattering their atomic gifts across space and time. Every element in your body tells a quantum story that stretches back to the beginning of the universe. You are made of star stuff that has been dancing the quantum dance since the first moments of creation. Right now, as you lie in peaceful stillness, that dance continues within you. Electrons flow through quantum probability states in your neural networks, somehow giving rise to your thoughts, your dreams, your sense of being a conscious observer in a quantum universe. The boundary between your inner awareness and the quantum world around you isn't as clear as it might seem. Perhaps consciousness itself emerges from quantum processes, from the eternal interplay between observation and possibility that we've explored together tonight. When you pay attention to your breath, you participate in the same fundamental process that collapses quantum wave functions into definite realities. Your awareness transforms the maybe of each moment into the actuality of lived experience. Scientists still don't fully understand how this happens. They can describe the mathematics of quantum mechanics with incredible precision. They can predict the behavior of quantum systems and harness quantum effects for powerful technologies. But the deeper questions remain beautifully open. How does consciousness arise from quantum processes? What determines which possibilities become real? Why does the universe seem to need observers to complete the transition from potential to actual? These mysteries don't represent failures of science. They point to something profound about the nature of existence itself. Reality seems to be structured in a way that preserves essential questions, that ensures wonder never completely yields to explanation. Perhaps this is exactly as it should be. Perhaps a universe that could be completely understood, completely predicted, completely controlled would be a lifeless clockwork machine with no room for creativity, growth, or surprise. Instead, we live in a quantum universe where uncertainty and possibility dance together, where mystery and knowledge interweave like the wave and particle aspects of light. Each answer reveals new questions. Each discovery opens doorways to deeper wonders. The ancient wisdom traditions spoke of reality as a kind of cosmic dream, a play of consciousness and energy that appears solid but remains fundamentally mysterious. Modern quantum physics suggests these poetic metaphors might be closer to literal truth than anyone imagined. You exist at the intersection of the known and unknowable, the measured and mysterious. Your body follows quantum principles that science can describe mathematically but cannot fully explain. Your consciousness emerges from processes that remain as mysterious today as they were to the first humans who wondered about the nature of awareness. This isn't a problem to be solved, but a gift to be appreciated. You get to participate in existence without needing to understand it completely. You get to dance with mystery, to live within questions that may never have final answers. As your breathing slows and deepens, preparing your body for sleep, quantum systems throughout your cells are shifting into the configurations that promote rest and healing. Electrons are tunneling through barriers that enable the chemistry of restoration. Probability waves are collapsing into the patterns that will generate your dreams. The same quantum principles that govern distant galaxies and subatomic particles also orchestrate the gentle processes that will carry you into sleep and back to waking tomorrow morning. In your dreams tonight, you might experience something like the quantum superposition states we've discussed. You might exist in multiple places simultaneously, be different people at once, experience impossible sequences of events that somehow make perfect sense within the dream's quantum logic. Perhaps dreams are what happens when consciousness relaxes its grip on classical reality and allows itself to flow more freely through the quantum landscape of possibility. In sleep, you might taste what it's like to exist as a wave instead of a particle, to spread out across space and time instead of being confined to a single location. Your dreaming brain will continue to follow quantum principles, but in ways that remain mysterious even to neuroscientists who study sleep and consciousness. The relationship between quantum mechanics and dreaming consciousness remains an open frontier, a space where science and wonder meet in questions too beautiful to answer quickly. Tomorrow, when you wake, you'll carry the insights of this quantum journey into your everyday experience. You might notice the mystery that hides within familiar things. You might sense the invisible connections that link you to everything around you. You might feel the gentle uncertainty that keeps life creative and unpredictable. The quantum world doesn't replace the classical world of your daily experience. Instead, it reveals the deeper foundations that make everyday reality possible. It shows you that even the most ordinary moments participate in the extraordinary dance of existence. Every time you turn on a light, you witness the wave-particle duality of photons. Every time you look at anything, you participate in the collapse of quantum possibilities into definite perceptions. Every time you make a choice, you might be expressing the same fundamental creativity that allows particles to tunnel through impossible barriers. Science and wonder are not opposites. They are dance partners in the eternal exploration of what it means to exist in a quantum universe where mystery and understanding, question and answer, consciousness and cosmos participate together in the ongoing creation of reality. As you drift into sleep, you join this cosmic meditation, becoming both observer and observed in the gentle quantum dance that weaves together all existence, forever and always, in ways more beautiful than any dream.